Hey everyone, today we are diving into an exciting topic in computer vision called MASA, that stands for matching anything by segmenting anything. If you ever wondered how computer can follow objects in videos even ones they have never seen before, you are in the right place. Let's start with a problem. Most object tracking systems can only follow things that they have been trained on. Imagine having a glasses that only can see cats but not dogs. That's how old tracking systems work. They are stuck with whatever they have learned on. But the w- but the real world is a messy. There are new objects, different lighting, and unexpected situation everywhere. That's where MASA comes in. So MASA is a new technology that lets computer track any objects in a video, no matter what it is, and it doesn't need special training for each thing. Pretty cool, right? MASA is built on a powerful tool called SAM, the segment anything model. Think of SAM as a super assistant that can outline any object in a picture automatically. MASA take those outline and learns to recognize the same object as is moved from one frame to another frame, even if it changes shape, size, and gets partly covered. So before moving into that, we will check what its research paper tell. Let's see its research paper. Hey, let me walk you through the MASA research paper in simple terms. First, first, I want to explain the problem the paper address. In computer vision, when we try to track objects in videos, most systems can only follow things they have already seen during training. So if I train a system to track cars, it might completely ignore a dog or a bicycle in the same video. That's big limitation. Now, the MASA, which stands for matching anything by segmenting anything, changes the game. With MASA, I can track any objects in video, even if the system has never seen it before. I don't need to train it on a special videos for every possible object. Instead, I can use regular image and MASA will still work. Let me tell you how MASA work. MASA uses a tool called SAM or segment editing model. SAM is like a digital pen that automatically draws outline around any object in picture. Once I have these outlines, MASA learns to match them from one video frame to next. So if I see a yellow ball rolling across the screen, MASA help me to follow it, even if it changes shapes, size, or gets partially hidden behind something. The paper introduce a universal adapted. Let me Yes. Uh, the paper introduced a universal adapter. I like to think of this as a plug that fits any socket with this adapter. I can connect MASA to any object detection system. That means no matter what detection tool I use, MASA can help me track object across frame. Why is MASA important? Because it lets me track objects I have never seen before. This is called zero shot tracking. It also works well with different settings like outdoor, indoor, or in poor lighting. According to paper, MASA even outperforms older methods that need lots of label video data. The applications of are huge. I can use MASA for self-driving car, security cameras, or robotics, basically anywhere. I need to follow moving objects since MASA doesn't need special training for every new objects. It it's much more practical for real world. To to sum up, the MASA research paper show me how to teach computer to track anything in video by smartly matching and segmenting object without needing ton of label data. It's a big step forward for computer vision, and I think it will make object tracking much easier and more reliable. Let's get to its implementation. We are going to inference MASA on this sample image. This is the standard sample image provided by MASA GitHub. You can see it's a video of Minions, which is a popular movie. To run inference using MASA, we just have to use this command line. As you can see, I'm using Python, providing the address to this for Python script and the video link, means video part to this, and uh, the output of that video, which is the inference annotated video, which is demo output, which is the folder which currently not exist, and also providing other configuration details like MASA grounding, GDyno, MASA checkpoints, which is the most important as it's providing the path to the grounding dyno.pt. Then I'm providing the text, or you can say a label of finding yellow minions, which is these objects in this, and also the threshold level of 0.2, and these are the other required flags. You can also add the flag to add segmentation mask. Now run this. As you can see, it's loading this in model for inferencing. Let's see, there is some error. Oh, we forgot to import this module. First, I'm using Python. Now it's installed. As you can see now, it's inferencing our video. It will take some time. Now the inferencing is done. You can see there is a demo output, and in that the inference result is there. Let's, if you see that if the inferencing, sometimes inferencing doesn't work as the folder is not present, you can create the demo output folder, then start the command line. It will create the result inside the demo output, but sometimes it does, it's a bug or a bug inside that code. You can comment into issue. So let's run the inference result. Let's perform MASA inference on another video. As we have already performed segmentation mask, let's only perform tracking. This is the video I'm going to use, and this is the parts to that video. It's a demo called Sodafish. I'm going to remove this flag called SAMMAS to just only perform tracking. Now let's run that. As you can see, I have already also given the label as fish, so it all only detect the fish. Now inferencing is happening. I will fast forward it. Let's see the result. Similarly, you can inference MASA on other video. Let's see other examples. With this, our tutorial on MASA is over. You can check our blog on our website in which we explain how you can perform MASA in greater detail and what MASA is and its architecture. Please check it out.